EMWorks is a company that's kind of a pioneer in CAD embedded simulation for electromagnetic, thermal, electrothermal motion application. The products that we have, which is EMS for SolidWorks and HFWorks for SolidWorks, are completely embedded inside SolidWorks, and these are products that are created keeping SolidWorks users in mind. So the user interface, the ease of use, the interaction that you experience with the software, etc., are extremely similar to what you are exposed to using SolidWorks. Now, as far as the company and its products are concerned, our first release came out way back in 2008, where we embedded both EMS and HFWorks for SolidWorks, and that's the time when we became the gold partner of SolidWorks. And since 2008, we have come a long way, and we have seen steady improvement in the features and that we have added to the product. In 2010, we coupled our electromagnetic simulations with thermal simulation, and now you can do electrothermal kind of multiphysics problems. Okay. In 2011, we coupled our electromagnetic simulation with SolidWorks motion, and now we can do coupled EMS motion type of problems. In 2012, we introduced the concept of solving our equations using multi-core. So all our solvers are now compatible with multi-core processors. This helps us to solve large problems in a fraction of the time that it used to take years back. Okay, and later this year in 2015, we have also coupled solution with a linear static type solution. EMS products are trusted by many SolidWorks customers. We had our first 100th customer in the year 2011, and since then we've grown steadily and acquired close to 500 customers towards the end of this year in 2015. Now, as far as the products and bundles go, EMS products are basically divided into two main products. One is EMS for SolidWorks, other is high frequency product. Today's demonstration and today's webcast is mainly catered to the electromagnetic part, what you see on the left-hand side of your screen, which is the EMS for SolidWorks. Okay, we have two products. One is EMS Professional, other is EMS Premium. EMS Professional contains 5 solvers: electrostatic, electric conduction, magnetostatic, AC magnetic, and transient solutions. And EMS Premium contains all of the things in EMS Professional. It also has coupled multiphysics solution with thermal analysis, with motion analysis. It has parametric simulation, and later this year we will be coupling it with linear static simulation as well. So all the EMS licenses are available as activation based license, and they are also available as network license. Now briefly we will talk about the various applications and the industries where our software features. Okay. So first we can talk about the linear actuator, solenoid, the motors, generators, that type of industry where the coupling with motion is extremely important. The phenomena is a multiphysics phenomena that happens with motion and electromagnetics. Next we'll take a look into the transformers and the inductors, that type of industry where these are electrical machines that are static, they don't move, but nevertheless they're an important class of problems. We also take a look at bus bars and conductors. That basically these are conductors working under AC frequency, under AC signals, and then we will take a look at some inductive applications that like inductive heating, etc., that makes use of AC current. And finally we'll take a look at some applications using permanent magnets, magnet arrays, and so on. Okay. Now let us start with the actuators and solenoids, that rotary and linear actuator industry. Okay. Now EMS is very widely used in this particular industry, and as you can see, where is it beneficial? It's extremely beneficial in using a simulation in basically computing the inductance of your coil. If you have a motor, if you want to understand what's the back EMF generated, you can compute the back EMF. You can also compute the induced voltage coming from a generator, for example. In the solenoid industry, EMS helps you to predict the motion of solenoids. Okay, it actually gives you the ability to visualize the velocities, the accelerations, etc., as a function of time. One can also use this product to help determine the right size of the coil, to size your coils, to find out the number of turns and the current, etc., for a desired outcome. And the force, the torque, etc., which are acting on the moving parts, the rotors and the plungers, can also be accurately computed using EMS. And this force and torque arises due to the magnetic field that is present, or the time varying magnetic field. And finally, you can use the parametric study to see how the changes in geometry is going to affect your results. So the EMS in the solenoid actuator industry is highly prevalent, and almost 30 to 40% of our customers reside in this particular industry. Next, we'll take a look at the applications of EMS, especially in the static electrical machines like transformers, inductors, bus bars, etc. And here, EMS can actually help to visualize the electromagnetic field inside your machine. It also calculates all the losses. For example, in the transformer, it can calculate the loss due to hysteresis, the core loss, the eddy current loss, etc. is all computed. One can study the effects of lamination of the core and its effect on the losses using EMS. Okay. And finally, we have this multi-physics capability to really couple electromagnetics with thermal, so that you can understand the temperature distribution inside your machine, and also compute thermal stresses and other quantities that are derived out of temperature. Next, we can move on to some induction applications. As far as induction applications are concerned, they're primarily AC magnetic or some kind of a transient magnetic, where the excitation varies as a function of time, either sinusoidally or say like a step function, a linear function, or any kind of function you can use in EMS to simulate induction applications. Now, EMS can actually help you to choose the right design of your coil, should you want to use it for, say, heating purpose. It can also help you to find out the temperature distribution due to the inductive heating. And finally, it helps you to visualize the eddy currents that are generated, and the losses and the heat that is generated due to these eddy currents. Last, EMS is widely used in industries that employ magnets and permanent magnets quite a bit. Okay, especially in designing novel products using magnetic arrays. So EMS can help you design a wide variety of magnetic arrays for various applications. For example, you have magnetic bearings, you have lifting devices, and so on, which use permanent magnets. EMS can actually help you to design those products. We can compute the forces and the electromagnetic fields inside in the surrounding space around your magnetic array, and also one will be able to visualize the interactions between various magnets in a magnetic array, and what is the cumulative effect of arrangement of magnets inside a magnetic array. Now this slide kind of gives you a complete picture of the various applications that are possible using EMS. What you see on the left hand side, we can start with the electromechanical industries, where we just talked about actuators, linear and rotary actuators. On top of it, we can design products like magnetic recording heads, voice coils, loudspeakers, solenoids, etc. Everything that uses the principle of electromagnetics can actually be simulated or helped in designing components using EMS. Okay. As far as the electromagnetic is concerned, now we're talking about electromagnets, where you have coils, you have cores, permanent magnets, etc. Those can also be simulated using EMS. Okay. In the power industry, we're talking about transformers, inverters, bus bars, so on. And finally, EMS can also be used to study electromagnetic interference, electromagnetic shielding, etc. Okay. And our applications range in wide variety of industry, from automotive to defense to aerospace, consumer products, energy, and even life sciences, and of course electronics. On the right, we also have another product, which is high frequency product for designing passive RF and microwave products, and that's called HFWorks. It's not really the main focus of today's topic, but to give you an idea of all the various problems that can be solved using our products, the HFWorks also form a very important part of electrical engineering area that we tackle. Now with this, the next I'm going to just show you a quick demonstration using EMS. And for this, we're going to have a magnetic circuit model. Here you have a magnetic circuit, you have a core material that's made up of some steel, okay, and then you also have a rotor material that's again made up of steel, okay, and then you have two coils here that has 80 turns, and it takes in about 1 amp per turn of DC voltage, okay, DC current. Now the idea is, using EMS, we want to study what's the distribution of magnetic field inside my circuit. The second thing is, I also want to study what is the torque acting on the rotary part, on the part that can move, or a rotor. And third is, what is the inductance of my coils because of this in this circuit. And finally, what happens if I make a design change, and how does EMS incorporate a design change and help me to do a simulation. Okay. These are some of the objectives of this study that we're going to do in this demonstration. As a first step to doing any simulation in EMS is to what we call as defining a study. So it's extremely easy to define a simulation inside EMS. The first step is defining a study, so we call it say study 1. We can give it a name. Here we can request the program to compute the circuit parameters, which means it computes the inductance of the coil and the flux linkages. Now the various analysis types are shown here. If you have DC type of excitation, we will use magnetostatic. If you have excitation that is AC or transient, we have AC magnetic and transient magnetic solutions that are possible. And for problems that involves charges and voltages, and you want to compute the electric field and so on, we have two modules here, electrostatic and electric conduction. Now parameterization is a module where you can vary your geometry. Any SolidWorks dimension can be a parameter, and it can be varied, and you can study the effect of variation of your geometry on the electromagnetic fields, forces, etc. That's the parameterization. As far as coupling multiphysics simulation are concerned, we can couple our solution to steady state thermal and also to motion. For this example, we're going to just select a magnetostatic study. Once the study is created, EMS creates a study tree. Now the next step is to define materials to your components. Okay, so let's select the coils, and then from my favorite materials, I select copper as my material of the coil. Okay. Next, we select the inner and the outer core, and here I'm going to apply a material, and I'm going to take a look at all the materials that come pre-packaged with the EMS. So EMS software comes readily available with a list of predefined materials. Okay. Now we have various steels here with its own BH curve. We also have other commonly used materials in the electromagnetics industry like conductors, cables, ceramics, permanent magnets, substrates, etc. All of them are present. And this is a fully customizable material library that allows users to actually create their own material and use them for simulation. Now, in this particular example, I'm going to use the material steel 1010 for my core as well as my rotor. And finally, you see that there is always air around your model, and it's very important to model the air geometry. And the idea of modeling the air geometry is to study the magnetic field in the air around your model. Okay. So next we define air as the model all around surrounding this particular modes that you see. You can go ahead and quickly update all existing components to make sure we get the latest design done in SolidWorks. So now we have this. We have now defined a study. We have applied materials. The next step is to apply coil. Okay. So EMS can have two types of coil, solid coil and a wound coil. A wound coil is made up of several windings of a wire, and here you select the components that comprise the coil. Okay. Next, we select the phase through which a current enters. So notice here that you get visually you get a feedback saying how the current is circulating inside the coil. So and then we simply tell the program the number of turns of the coil and the current per turn, and that concludes the definition of the coil. We do a very similar definition for my second coil here. Select the wound coil. I select the entities that comprise the coil, and then I pick the phase through which the current enters. I specify the number of turns and the current per turn. Okay. Now with this, the coil definition is over, so I'm going to go ahead and hide the symbols. Next, it's very important for me to compute what's the torque acting on my rotor here, of rotor part of the circuit here. So I request the program to give me the torque acting on the rotor. Now with this, the definition of the setup is complete. So we created a study, we defined the materials for all the components. Next, we defined coils. We have two coils here, so we defined the coil. And finally, we asked the program to compute the torque on the inner part. Okay. With this, we are ready to solve the problem, so we can launch the solution. So as mentioned earlier, EMS makes use of multi-processors to solve the problem. So in this particular example, I'm actually solving this problem using a 4-core computer, which is with 8 GB of RAM, Intel i7, and now this particular problem, which uh, can be solved in less than a couple of minutes here. We can see the solver being launched. So the number of elements is almost close to 100,000 elements in this particular problem, and our multi-core solvers ensures that this can be solved in actually less than a minute. Now, once the solution is complete, we are now ready to take a look at the various results of our particular solve. Okay. And what kind of results are possible using EMS? The first thing is we requested the program to compute a few things. We asked the program to compute the torque. For example, the torque about the z-axis here is being computed. This is the torque acting. It's about 1.5, 1.35 millinewton meter is the torque about the z-axis acting on this particular inner rotor. Next, we requested the program to compute the inductance. So we have now both the inductance of each of my coil. So it's about 2.2 millihenry, and this is the self-inductance, and there is also mutual inductance that is computed by the program, and also the flux linkage associated with each of the coil is computed. So all the engineering quantities that are required are all arranged in the form of a result table. Next, EMS is a 3D visualization software. So one can actually visualize the results and take a look at the results on a 3D space. So what I mean by that is I can take a look at, say, for example, my magnetic flux density in a 3D model. So I can zoom in and I can look in areas where I have high values. So it's about 1.35 Tesla, about 0.135 Teslas in this location, and this gives me the idea of my magnetic flux density. Next, I can go ahead and create a section plot. A section plot helps me to visualize regions in my model, inside my model. So I can actually go inside my steel and actually visualize how my magnetic flux changes. I can also take a look at a vector plot of my magnetic flux density. So I can make it a vector plot, and so this gives you the same results, but now more as a vectors, and you can now see the movement of the flux as a vector from this coil all the way and completes the magnetic circuit. Okay. So now this is possible to visualize as a vector. And one can also next take a look at the magnetic field intensity. For this, I'm going to go ahead and turn on my air region that was inside. And now I can take a look at my magnetic field intensity in my air. This is my magnetic field intensity. Take a look at them. So this is a whole host of post-processing features are available. Now what happens if I do some kind of a design change? Okay. Now what I'm going to do is I'm going to go ahead and create a design change. I'm going to go and hide this inner air and edit this particular part. and I'm going to change, make some geometry changes. Edit the sketch and say, move this a little bit closer. Now I have a completely different magnetic circuit, which actually has a different geometry. Okay, and now when I come to EMS, I can actually create a new study, and I call it study 2. Now in study 2, I want to go ahead and request the program to compute my inductance. And here, what I'm going to do is I'm going to go ahead and drag and drop things that I've already defined in study 1 back to study 2. So everything that I defined, like coils, requesting torque on a component, my materials, etc., can actually be used from one study to the other. So as soon as I drag and drop all the details of one study to another, so I get all of these. So actually my coil definition is quite intact. So I can already see my definition that was done earlier can actually be used for this simulation as well. So my coils are defined. I am requesting the program to compute the torque acting on my component here, a rotor component. And all you're required to do is rerun the simulation and once this is the simulation is launched, we are ready to take a look at the results. And anytime during the presentation, if you have any questions, please feel free to type them in the chat window. And at the end of the presentation, we'll be happy to answer some of your questions. Okay. Again, now once the solution is complete, now we can take a look at the results for our new geometry. So you can see how the variation of magnetic flux is in this particular new geometry. As before, we can do a section plot to see what happens inside the model. We can also do some kind of a vector plot. And take a section of it, and that helps us to clearly visualize my vectors, my flux vectors inside my magnetic circuit. So it actually, you can take a look at all the field lines that go as a vector plot. Okay. And what's more important is go back to the result table. Now you have a new torque, which is about 1.5 millinewton meter that acts on this particular geometry. And the inductance matrix is also computed. Notice that there's not a huge difference in the change in the inductance, and the flux linkage is also computed for my new geometry. Okay. One of the neat principles that allow you, that EMS offers you, is the ability to compare across two designs. So I have a couple of designs that are very similar to what we did, and now I can actually compare across design. So for example, if I want to compare my torque from design 1 and design 2, so I can actually take a look at the various torque. So for the first geometry, the torque acting was about 0.13 millinewton meter, and this is about 0.15 millinewton meter. So there is a variation in the torque from the first study to the second. Similarly, you can compare the inductance between, so the self-inductance, the changes in the self-inductance is there between study 1 and design 1 and design 2. And also we could compare the flux linkage as well between the two studies. Okay, so this feature allows us to neatly compare between various simulations. Now, the last thing that we want to show before moving on to this one is the ability to create reports. So I can actually generate a report using EMS. And these are automatic design reports, either in the HTML or Microsoft Word format. So I can actually pick the ones that I'm interested in, the result table and so on. So I can actually create a report. So EMS automatically creates a Microsoft Word report based on the simulation that I did. And in this report, we include various things like the materials that were used for the simulation, what were the details of the coil, what was the requested torque under what body, and so on. And also a lot of results are also, result tables are all here. For example, the torque results here, the resistances in my coil, the inductance matrix for my coil, the flux linkage, etc. there. And not only that, all the plots are also automatically embedded inside this Microsoft Word report. So this Microsoft, because it's a Word report, one can actually edit this this one, and I can and one can type these things inside SolidWorks. So it's very handy, the report feature. So it automates a lot of design reports that people have to make, engineers make for reviews, for sharing with colleagues and with the customers and so on. So it actually automates this process quite handy. Okay. With this, pretty much we conclude this short demonstration. Obviously, we don't have enough time to cover almost all the features of EMS. So that brings us to our next point. So is where can you get additional resources to learn more about this product? So you can visit our website emworks.com, and there you can see testimonials, you can see case studies, you can see white papers. And you also have a link to our YouTube video channel, which has over, I think, over 30 or 40 videos that highlights various aspects of the program, and you can learn more about it through our videos. Obviously, you can, if you have any questions, you can reach us. Our 1-800 number is given here. It's also available on our website. So our support engineers and our sales team will be very happy to answer your questions. Obviously, you can go online, and we have a download version, evaluation version available for viewers today, and you can register to download your free 15-day evaluation version of EMS on our website. And as a token of appreciation, we thank you for attending today's webcast. And as mentioned in our earlier email to you, we will host a few more of these webcasts over the next week, and we will be selecting 2 lucky winners who will receive 1 year free license of EMS Professional with full technical support. and we will notify the winners before the end of this year. Okay. Again, we thank you all for attending today's demonstration, and right now I will be happy to take a look at some of the questions. So if you have any questions for me, please feel free to type it down in the chat window and I'll be happy to answer them. There was one question: does EMS support magnets that are uh, radial and so on? Yes, the answer is yes. You can define any type of permanent magnet inside EMS, and you can define your own coordinate system, and you can define the direction, north-south direction of your magnet in EMS. So it's quite arbitrary, and you can define it. There's another question. It talks about what version of SolidWorks is EMS compatible with. Now, we are currently in EMS 2015 version, and very soon EMS 2016 is going to be released. So EMS 2015 works with SolidWorks 2014, SolidWorks 2015, and SolidWorks 2016. So always our EMS products will work with the current version of SolidWorks, one version before and one version later. Now there's another question which talks about EMS and its relationship with SolidWorks motion. Yes, when you couple electromagnetic simulation with SolidWorks motion, then you can actually transfer the electromagnetic, the forces and torques that come as a result of EMS product, that can be transferred to SolidWorks motion, and you can use that values to drive a motion, and this communication goes back and forth, and that is how we employ multiphysics, motion and electromagnetic study in conjunction with SolidWorks. Is it possible to do thermal simulation in EMS? The answer is yes. One can couple electromagnetics with thermal in EMS, where we say couple to thermal. In that case, what EMS does is, for example, the ohmic losses in your coil, it computes the temperature rise in the coil due to the current going in the coil. If you have induced currents, for example, if you have AC excitation or transient excitation, or if you have conductors moving and cutting across magnetic flux, then you have currents which are induced, and this induced currents or eddy currents also causes heating, and this can also be captured in EMS thermal. Does the EMS program work with SolidWorks subscription license? No, the EMS actually has its own license, activation-based license. So if you are already a SolidWorks customer, what you need to do to use or try EMS program is, when you purchase or use EMS, you have your own activation serial number for EMS. So you can put that in, you activate your program, and you can use it. And the subscription service for EMS is different than the subscription service for SolidWorks. So you could actually, the maintenance for EMS entitles you to all the updates during your current maintenance period, and also entitles you to technical support over the phone and internet with our support engineers. there is a question about the energy calculation. Is the energy calculated representing the electrical input given to the coils, including all the losses? Actually, the energy is the total energy in the entire domain. So it does include the input electrical energy. It does include the losses if there are any. Also the losses in the core and so on. So the energy is the total energy of your component. Okay, I think with this we can conclude this presentation. Once again, I thank you all for joining us today, and we look forward to answering any of your queries. And this is. So we look forward to all of your queries. So and please feel free to visit our website or give us a call should you have any question. There is just one more question. I think how can EMS calculate the mechanical energy produced by the rotor? That's a good question. So actually, the rotor is actually inside a magnetic field. Okay, the magnetic field the magnetic field exerts a force on a ferromagnetic substance. The rotor is a ferromagnetic substance. So EMS is able to compute the entire magnetic field in the domain. And it also knows that there is a ferromagnetic substance in the form of a rotor that is sitting inside the magnetic field. So obviously, there is a force and a torque exerted on any ferromagnetic substance that is present inside the magnetic field, and EMS will be able to compute that particular value of, say, in this case, a torque and a force acting on the ferromagnetic substance is the rotor, and and the torque is the primary quantity that you can use now, and then that torque can be used to drive this rotor. And obviously, as the rotor moves, the torque varies and so on. So even this type of coupled motion and EMS simulation is possible today. So if there are no further questions, we will sign off now, and we thank you all for attending this webcast on EMS for SolidWorks, and we look forward to hearing from you or